In this video, we're going to go through optimizing quadratics, and if you haven't already, please check out the graphs of quadratics. A lot of this might not make sense without that video. So when I talk about optimizing quadratics, we're talking about figuring out our vertex point. Usually, when we're talking about this in context where we have a word problem, we're talking about trying to find maximum profit or maximum revenue, maximum efficiency, some sort of maximum. So a lot of these are going to have a negative leading coefficient. So if you look at the ax squared term, this is going to be less than 0. So let's look at an example where we have a context problem. So last year, 120 people entered a tournament with an entry fee of $40. Each increase of $5 results in 10 fewer people entering the tournament. At what price will we optimize the profits? Already you can see this is a very useful question. This is the kind of thing businesses do all the time. We want to know at what point will we make the most money. And there's that trade-off. Sure, you increase the price, but less people will come in, or vice versa. If I reduce my price, more people will come in, and it would make sense there is kind of a sweet spot. And finding it can be tricky. However, we have the ability to calculate it. So if we think about it in this case, and this formula really holds true for a lot of these kind of context questions, our profit is going to equal our price per whatever. In this case, we're talking an entry fee, but we could be talking about price per item, price per plan, whatever. So for now, I'll put price per item times the cost, or the quantity of that item. Sorry. So amount that I sell. In this case, how many people enter the tournament? So if we look at these individually, it helps to do this because then we can create expressions for just these two individually and then build our equation. So looking up at this, it seems to me that everything depends and is affected by price. If I increase the price, that dictates the number of people. So the price will dictate the number of people. The number of people is dependent upon whatever the entry fee is. So if we think about that, we can make expressions for these two individual pieces and then build our equation from there. So if I'm thinking about the price per item, okay, it was $40 before. And how is it going to change? Well, first I have to define a variable. So we're going to let x be the number of times the price is raised $5. So that means that, okay, if I increase it once, it becomes $45. Twice, it becomes $50. Now I have to think about a way I can write that as expression. In this case, I think 5x. And that would be my price. Now I can do the same thing with the quantity. If I look here, 120 people entered last year, and I know that 10 fewer people are going to enter every time I up the price by $5. So minus 10 times x. So if it was $10 increase, I would lose 20 people, so on and so forth, hence the multiplication here. Now if we look at this, we have an equation that we can work with. Building it without thinking about it in this way is very, very difficult. So I highly encourage to go that method. Think about, okay, can I just make an expression for the price and just make an expression for the quantity, and then we can break it out from there. So now that we have our equation, before we can find the maximum, we have to get it into standard form. So in order to do that, we have to expand these two binomials. Since we're multiplying them, there's a couple ways we can go about it. We can do a double distributive property, if that's your preference, where you take the 40 times the other 2 in blue there, and you take the 5x times the 2 in blue, and then you combine like terms. You can do FOIL, or the method that I personally like, I call it Smiley Guy. It just helps me kind of keep track of everything. So I just kind of draw it out, and then I do the multiplication. So 40 times 120, that's going to be 4,800, and it's positive. Okay, we're going to have 5x times a negative 10x, which is going to be negative 50x squared. Forgot about that for a second. Then we'll have 5x times 120, which is going to be 600x. And then we're going to have 40 times negative 10x, which is going to be negative 400x. We're going to put it all together with all these terms that I've got in white here, and we'll just recreate our equation in standard form. So our profit is going to equal negative 50x squared. In this case, I'm going to just go ahead and combine those two while I've got them here. So this will be a plus 200x plus 4800. Now that we have it in standard form, we only have to look at our A term and our B term. So in this case, negative 50 for A and 200 for B. We're going to go ahead, use our vertex formula. So x is going to equal negative B, so negative 200 over 2 times A. In this case, negative 50. Now be very careful with your negative signs when you're going through these. That's a very common place to make a mistake. So we're going to go through, we're going to simplify, so we're going to have negative 200 divided by negative 100, which is positive 2. Now I have to really think about what this means, what that 2 is, and that depends on what I called x. Now recall back, I know it's not on the screen now, but x was the number of times we increased the price by $5. So this tells me we want to up the price by 10. Which means that we are going to have our maximum profit when our entry fee is $50. And that would be the solution to this question.